I know what you're thinking. You're thinking, what the heck is hexadecimal? Well, welcome back to Learning with Merritt. I am Mr. Merritt, and today we're going to set the base to 16 with hexadecimal. Before we talk about hexadecimal, we need to review our decimal system. The decimal system is the one that we all know and love for using with our math. And this is a base 10 positional number system. And what that means is that we have 10 distinct digits, 0 through 9. We have places all based on powers of 10. So we have the ones place, the tens, hundreds, thousands, and so on to the left. Then to the right, we have the tenths place. I'm going to put a little floating point right there so we know what we're dealing with. Then we have 1 over 100. That's our hundredths place. 1 over 1,000, our thousandths place, and so on to the right. These are all based on powers of 10, as I said. That's 10 to the 0, 10 to the first, 10 to the second, and 10 to the third. Over towards the right, we have 10 to the negative first, 10 to the negative second, and 10 to the negative third. We'll place some lines to break these up, make them a little easier to read. And now if we have a number like 421, we know this is for our hundreds. We know that the 2 here is for the tens, and we know that the 1 here is for the ones. Very simple number system there. And if we understand this number system, it's not that hard to apply it to another number system where the base is no longer 10. Instead of 10 today, it's going to be 16. All right, the hexadecimal number system. Hexa meaning 6 and deci meaning 10 gives us the name for the base 16 number system that we will be learning about today, and that uses digits 0 through 9 and has an interesting problem now for digits 10 through 15. What do we use? Well, if we write them out, 10, 11, 12, 13, 14, and 15. We need a single symbol to represent all of these values, and let's use something that we already have. Let's use letters. So A, B, C, D, E, and F will take up those spots for us, and now we have 16 total symbols that we can use to represent values 0 through 15. The places in this number system, here we are going to start with the ones place, which is 16 to the 0 power. The next place to the left is going to be the 16s place. This is 16 to the first power. Then we have 256, that is 16 to the second. 4096, which is 16 to the third. And we're going to stop there because it's just powers of 16 to the left. We're going to break these up to make it a little easier to see what we're doing here. Now, when we're dealing with this number system, there are a couple of important things to know. One of them is these two places right here make up a single byte. So the 16s place and the ones place is enough for a single byte of data. That means we can represent values 0 through 255 in those two places. And that's actually one of the reasons why we use this. Instead of using 8 places in binary, right? Instead of going 0, 0, 0, 0, 0, 0, 0, 0, we can just do 0, 0 like that in hexadecimal. And that is the exact same value. Okay? So we take up a much smaller area when we do this. We also have a new interesting problem. Let's say that I write 1, 0 in hexadecimal here. How do I tell the difference between this and, for example, if I write that, that, and that? Those are 3 different numbers in 3 different number systems. How do I tell the difference? Well, for hexadecimal, there's actually several ways. In hexadecimal, we will use 0x, or you might see a hashtag, or you might see 0h. These are all different symbols that you may see. So in order to indicate a hexadecimal number, I am going to write 0x and then the number that we are using there. Just like that. All right, so let's say that we're going to convert a number from decimal to hexadecimal. We need to make sure that we have our places here, so we are going to start with ones and the 16s place here, and if we needed, we could add some more places. But right now, this is just 1 byte, and it represents values 0 through 255. So what we're going to do is we're going to say, all right, what number do we want to convert? We're going to convert 97 into hexadecimal. So the first thing I'm going to ask myself is, what is the largest value here that will go into 97? Well, that happens to be 16. So I need to figure out how many times will 16 go into 97. So what I'm going to do is I'm going to say, all right, 97 divided by 16. Now what this gives me is a number. It gives me 6.0625. Now what we're going to do is we're going to take the whole part here. The whole part is going to go in the 16 spot. So we have a 6 there. Now to figure out the 1 spot, we're going to take this piece right here, just this piece, and we're going to say for the 1 spot, 16 times 0.0625. And what that gives me is the number 1. So 97 in hexadecimal is 0x61. All right, this time we're going to convert 158 into hexadecimal, and we're going to say, all right, which one of these goes into 158? That's going to be 16. How many times does 16 go into it? So we're going to write 158 divided by 16, and what we're going to get from that is 9.875. The 9 is going to go into the 16's place here, and we're going to take 16 times 0.875 to figure out the 1's place, and that will give us a number of 14. Now, what is the hexadecimal digit for 14? That is going to be E. So our final answer will be 0x9E is 158 in hexadecimal. All right, this time we're going to convert the number 235 into hexadecimal. I'm going to say, all right, what's the largest value in the places that will go into 235? And that is 16. So we're going to say 235 divided by 16. That will give us a number here of 14.6875. So that 14 is going to go in the 16's place here, but we can't use 14. We have to use E, because that is the symbol for hexadecimal. Now we're going to take 0.6875. We need to multiply that by 16 to get our 1's place here, and that is going to give us 11. But again, we can't use 11. We need to use the symbol in hexadecimal for that, which is B. So our final answer here is 0xEB is the hexadecimal for 235 in decimal. All right, let's say we have a much larger number that we need to convert into hexadecimal. And so there is a much easier method than trying to remember all of the very large places in hexadecimal. We're going to take the value 8,025 here and convert it. And we're going to use the divide by 16 method to do this. So we're going to say 8,025, and we're going to divide that by 16. Now this gives us a number of 501.5625. We're going to leave the 501, and we're going to take just the fractional part here, which is 0.5625. We're going to multiply that by 16. So we're going to say 0.5625 times 16, and what that is going to give us is the number 9. Now I'm going to take that number, and I'm going to write it over here as a part of my answer. That's going to be our 1's place. So now I'm going to erase this so that we have some room to work. And we're going to leave our 501 here and use it. So now we have 501. We're going to divide that by 16. And what we get there is 31.3125. We're going to do the same thing here. We're going to use 0.3125. We're going to multiply that by 16 to get our remainder here. And what that gives us is the number 5. So we're going to write the 5 to the left of the 9. That is going to be the 16's place for our answer. So we're going to keep going here. I'm going to erase this again. Now we're going to start with 31. We're going to divide that by 16. And what this gives us is 1.9375. We're going to take that fractional part, 0.9375. We're going to multiply that by 16 again. And what this gives us is the number 15. Now 15 in a hexadecimal digit is the letter F. So we're going to put F there. That is going to be the 256th place for our number. And finally, we have the number 1, which is lower than 16. So what that means is if I do 1 divided by 16, that is going to give me 0.0625, just like that. Now, rather than going through the same method that we just did, because it's lower than 16, I know it's just going to be 1. So I'm just going to write a 1 there. So any number that's lower than 16, once you get to this point, right, it's just going to be your final value. So this is 0x1f59. That is 8,025 in hexadecimal. Let's say that we need to convert from a hexadecimal value here to a decimal value, and we have the hexadecimal value 0x65. And what we're going to do is take a look at the places we have. We have 5 in the ones place and 6 in the 16s place. So what we're going to do is we're going to say 5, because it's in the ones place, plus we have 6 16s, so that's multiplication. So we're going to do 6 times 16. If we do the multiplication for that, that comes out to 96. So what we have is 5 plus 96, and that is going to equal 101. So 0x65 in decimal is 101. All right, let's say that we have CF as our hexadecimal value this time. So we're going to start in our ones place. We have 15. We're going to add that. We have C, which is 12. So we're going to say 12 times 16, because it's in the 16s place. If we do 12 times 16, that is 192. Good job. I bet you did that in your head. All right, 15 plus 192 is going to give us our final answer of 207. All right, so 207 is our answer for 0x CF in hexadecimal. Let's say that we have 0xd6 here as our hexadecimal value. We're going to convert that to decimal. So what we're going to say is our 6 is in the ones place, so we have 6 plus. Now we have D in the 16s place. D is the number 13. So we're going to take 13. And we're going to multiply that by 16, which that will give us 208. We're going to do 208 plus 6. That will give us a final answer of 214. So our hexadecimal here is 214 in decimal. All right, now let's say that we have a larger hexadecimal value that we want to turn into a decimal value. We can use something called the multiply by 16 method, and it is basically the inverse of the divide by 16 method that we use to go from a decimal value to a hexadecimal value. So let's say, just for giggles here, that we have 0xabcd, and this is going to be a fairly large decimal number, but here's what we're going to do. We're going to start here at A, and we're going to multiply that by 16. So that's going to be 10 times 16. Then what we're going to do is we are going to add the next place, which is going to be B here. So we're going to do plus 11. If we do that, what we get is the number 171. So now we're sitting here at the B place, and what we're going to do is we're going to multiply 171 by 16 again and add the next place. So if we add the next place, that is going to be C, which is 12. If we do this, the next value that we get is 2,748. Sorry, 748. Now we're going to take this over here. We're going to say 2,748. We're going to multiply that by 16 and add the next place. So we're sitting here at C. We're going to add the next place, which is D, and that is going to be 13. If we do this correctly, what we end up with is the number 43,981.